In this lecture, we're going to talk about the work done with respect to variable force and constant force. First, we're going to talk about the constant force. Let's see the example or definition of it. Work that has been done with constant magnitude and cover distance with constant angle. Like, suppose a body with a mass or particles in it, and a person is standing here and pulling this body in this direction, like he's applying force like that, and it covers the distance like this in the straight mode, in the forward mode, and it has a angle theta. Now there's a plane surface, and this body can cover the displacement till that with a constant force and a constant angle, and that's all about the work done by a constant force. यानी कि खाली एक कांस्टेंट फोर्स लगेगी इस बॉडी को इस पोजीशन तक पहुंचाने के लिए. लेट्स सपोज कि 3 न्यूटन फोर्स is applied on this body, and it covers the displacement of 3 meter. So we can say that it will cover the displacement of 6 meters with the same constant force. Now that's the call work done by a constant force, and we can draw a graph just according to this. We can draw a graph. Here the 3 is here, and here the 3 is here, and this is called work done with a constant force. Okay, now let's talk about the work done by a variable force. The constant force can be determined by the word constant. A variable force can be determined by a word variable that can be taken as the word difference, like difference. Okay, difference, and this can be constant. Constant means constant. So the definition of the work done by variable force is the work at which the magnitude is not constant. Like, just suppose a body here has to cover the distance like this. Now suppose a mass, a container, or a body that is a heavy body. A person has to make it cover the distance up to here. Like, let it be in the point A and that be the point B. Now when the person applied force to make it migrate or make it cover the distance till here, he will apply the force of 3 Newton, and the body will cover from here to here. It will cover the distance of 4 meter. So what about this inclined path? More force is needed. Like, if it covers the distance from here to here, approximately 10 Newton force is needed, because the force is being applied opposite to the gravitational force. So we can say that the magnitude is not same, so it needs not a magnitude that would be constant, it needs a variable force. We can say that it's a variable force. Now here's a common example that is of Hooke's law mass spring system. So just suppose that if a body is here, like we are stretching it to the distance like here, and this is the mean position of that object, we can say that more this needs 3 Newton force to stretch it till here. Now we will just leave that body, and it will just cover the distance that is a little bit back towards the actual this is the distance A, and this is the main distance B. So from A to B, it just covered the distance that is little bit. In the third diagram, it covers distance a little bit more, but in the fourth diagram, it just come back to the force or come back to the mean position. Here, the force applied would be approximately 1 Newton. So there's a huge difference between 3 Newton and 1 Newton. So we can say that it's not a constant force applied. It's a variable force that is changing according to the distance and according to the mass. So we can say that it is a work done by variable force. Now how can we just drive these calculate these type of forces? We can calculate it with net force like F1. Just suppose that the force applied here is F1 and the distance is F1. From here the force applied is F2 and the distance is F2. Here the force applied is F3 and here the distance is F3. We can calculate all these forces and distances by a formula or by sum up these forces that is applied at different distances at different force. We can just sum up it by the formula of the work, that is F is equal to F into D cos theta. So we have to just put the negative forces that are applied, like here I'm just going to calculate 3 forces, that is F1, the distance covered is x1, then F2 less force, sorry it's the F2 less force and that covers the distance, and F3 that is the most least force and it covers the distance x3. So let's just calculate it. The net work that is done is equal to F1 x1 cos theta, then F2 x2 cos theta, F3 x3 cos theta. Like this we have to just put the number or the certain value that is given in the question to this formula and we can just get the work that is done at the net condition or the net work that is done. Or we can say that sigma Fn delta xn. Here the sigma signs just tell us the sum of, sum of all the forces that has been applied. It is written as the Fn delta. Delta means a change in the distance, xn. So like this we can just calculate the value of net work done on a object. That is all about the work done by variable and work done by constant force.